Guten Tag. Hello. Hello. My name is Carsten Strampe. I'm the General Manager of IMAGO Technologies. We are a German company, and I like to introduce Vivien Möslang, our native English speaker. We share the presentation today, and Vivien is also our speaker on our YouTube video channel IMAGO TV. So if you like to see and hear latest news from IMAGO, feel free to take a look on IMAGO TV. The agenda, a short quick history about IMAGO Technologies, and the first topic is that I like to explain some differences between today's evaluation board and vision products to realize a vision system. Then we will show you some of our products called Vision Cam and Vision Sensors. And after we come back, how you are able to develop your vision system. What are the tools behind to realize a quick application? Another product is our, let's say, traditional vision box. Since 1998, IMAGO is inventor of a huge number of vision boxes. And then finally, we will speak about the comparison of ARM-based vision systems versus Intel or x86 architectures. And finally, we close with some topics on our services and the level of information and trainings we provide.
Okay, so hello and welcome from me as well. Thank you for the nice introduction. And I'd just like to start presenting what IMAGO Technologies is, since when we've been around. We've been around for quite some time. We were founded in 1994, so 24 years ago. And for 20 years, we have been inventing and producing embedded vision computers and also have experience as system supplier. So that makes us a very established and experienced supplier and manufacturer, but we also have ideas and innovations for the future, which today will be about, basically. So, as you can see, we develop smart cameras, embedded vision computers, and from single-core over multi-computers to today's multi-core architectures, especially with a focus on ARM. And with the exception of the x86 devices, we also have long-term production of our hardware, which goes up to 12 years of lifetime altogether. So long-time availability is very important for us to provide that for our customers. And for this year, concerning the future innovations, what we have new on the market this year are smart cameras, especially in the line scan area, from starting at low cost up to very high end. And then what we will see later on as well, vision analyzers, which we call vision boxes, starting at x86 processors up to the 8-core ARM Cortex A72 processor. And also new this year is an Industry 4.0 real demand approach with the Edge Box, which enables private cloud computing in your factory or machine.
Okay, the next slide shows some aspects. I like to underline that between an evaluation board from a processor vendor and a product ready for the development of a vision application, that there is, from our experience, really a big gap. Because I would say today 80% of our products is firmware and software development. The reason behind is that there are a lot of stacks They need to be developed, starting with the bootloader, with firmware, the drivers to control all the I/Os, control all the interfaces, and to build everything inside of a well-qualified SDK. So together with the integration of third-party libraries, for example, Helken Embedded, our target is that we provide not only the hardware, it's a basic system where you are able really to start with a vision application. And I think this is a quite big difference, that we do not want that you start with installing some drivers, some cameras, whatever. Our idea is that you can immediately start with the programming of your application. In industrial applications, it looks like in these images. So cameras are installed in a machine. On the top left side, it's a smart camera, or vision boxes are installed in a cabinet. And the normal operation is 24/7 operation. We always take care about the power consumption. Our intention is to provide fanless devices. And another aspect, mainly in the area of machine vision, is the long-term availability of components. So as a producer of electronic hardware, we take care about this kind of long-term availability.
Now coming to our products on the camera side, we develop intelligent cameras and vision sensors. The technical information is coming for you to read. I just wanted to give you a short overview or idea about what our vision cams and vision sensors can do. So they may look like a normal vision, like a normal just camera, which can only take pictures, but it's a complete vision system inside. So all the image processing takes place on the vision cam itself, and it has the computing power of a former IPC. And what you see on the pictures is our new line scan camera. It's the first smart line scan camera on the market, and what we also have new in our portfolio is a vision sensor, which is a very, very compact solution. Which all of these run on ARM processors or also dual-core floating point DSP. We have considered all the interfaces that are important for our customers and sensors with up to 5 megapixels. And our devices are already in series production, so for whatever kind of machines, applications you need them. You can port your own application into a vision cam and sell it as your personal smart camera into your specific market. So that's basically what makes us different from others, is that you don't buy like a finished product which may not exactly fit your problem or your solution that you're trying to find, but you can develop yourself so that it matches your requirements exactly.
Yes, let's take a look into the details of the block diagram. So the key processor is an ARM Cortex A15 dual-core processor, and our benchmarks, all of them are made with vision application. They show really a big improvement compared to ARM 9 processors. As the processor comes from the vendor Texas Instruments, there is also an accelerator with a dual-core DSP, but for a normal application it's not necessary to think about the DSP. It's only, let's say, to have that in the background if it is necessary to do some pre-processing, to have some accelerator. Then we can speak about the dual-core DSP. Around the processor, we have an FPGA. The FPGA is responsible to manage the different CMOS sensors. We provide 1 gigabit per second Ethernet interface. In a normal application, it's not necessary. Normally, 100 megabit is okay for data transfer, but 1 gigabit is very good if you like to see much faster some live images. And another aspect is, with this kind of smart camera, you can also do some pre-processing. So do a pre-processing inside of the camera, transfer the images, and then do a final processing on a standard IPC. We provide, in addition, some opto-decoupled IOs. We are able to generate flashed illumination with integrated LEDs or with external connected LEDs, and then other typical interface of a typical computer. Here we have one block. It's called real-time Ethernet. As you know, there are a lot of different field buses in the market, and the processor itself is able to support a real-time Ethernet, let's say like EtherCAT or Profinet. So the real-time stack of the field bus is running inside of the processor, and then there is here communication with the ARM processor, and therefore it's not necessary to realize additional hardware for this field bus support. The next slide goes into the way how to develop the application, and a lot of engineers are familiar with Microsoft Visual Studio. It's a well-known, established environment to program, and therefore in former times also Eclipse has been very popular. But as a lot of people have Microsoft Visual Studio, there is a way with a plug-in for Microsoft Visual Studio to support the programming of the Linux camera. And here I have the code. The code is transferred into the camera. On the camera, the compiler is running, compiles the code, and gives back also some debugging information into Microsoft Visual Studio. So a very easy way to transfer your Windows-based project into a smart camera. And then we have here some additional interfaces. So this new concept has been tested inside of IMAGO with real application, and it really works fine. And the compiler inside of the Vision Cam itself is really fast enough to do a fast compilation of your code. Okay. Vivien.
Yeah, so I've already presented to you the vision cams and vision sensors, and now this is our basic focus that we've been focusing on for 20 years now, what we call the vision box. Now you might be asking yourself, okay, what is a vision box? It is actually a vision analyzer, and it's able to manage all of your cameras. It has a lot of inputs and outputs and machine network interfaces that you can decide yourself which ones are important for you in your system. And as IMAGO has this long time experience on that market, our experts know very well what is needed inside a machine in industrial embedded vision, and we know how to do the best approach, whatever you might need. And in the end, you can decide if it's going to be a very complex system or just a high quantity board level version. So basically, the decision is up to you what you can do with our different vision boxes or vision analyzers. ODM is the keyword. As you probably know, that means original design manufacturing. So that is our approach here.
Okay, so today we provide x86 based vision boxes, and now and in the future it becomes more important also the area of ARM processors. And we have the Linux operating system, we have Windows operating system. So we are familiar with both technologies. And let's say our intention is to provide to you the best vision box. To come to a decision which is, let's say, the best solution for just your needs, your application, we have difference between the operating systems. We have already a lot of experience to compare the behavior of Linux versus a real-time Linux, so a real-time extension of the kernel. We can speak about the benchmarks, the computing power regarding the different CPUs, and 3 times interfaces. A vision application is not the realization of software code on a CPU. This might be the first step, but every vision application is running in an environment on different interfaces, not only a camera. So we speak about your needs on interfaces. Our modular concept is able to provide only the interfaces for your needs. The roadmap to smart cameras, I think, is more and more important, as embedded vision is a topic here also at the Embedded World 2018. So the discussion with you, does it make sense to port your PC-based application into a smart camera, is a question, yes or no. Lifetime, also very important. Maybe you know a typical commercial Intel processor is available for a few years. There is a, let's say, line of embedded Intel processors. They have an availability of 5 years. Maybe after 5 years you think, okay, now it's time for the next generation. But there is also a market who asks for long-term availability. And so we need to take care about the processor vendor. For example, as Vivien has shown here with the Blue Vision box, there inside we are using a processor from NXP. And this processor is used in the telecommunication market. So at minimum 10 years available. And all the other components inside of a vision box, of course, we take care about the long-term availability. Another aspect is the real-time behavior. And not only the application itself, also the interfaces, the illumination, the camera data. Very, very important, because at the end your application needs to run in real time, whatever you define as real time. Porting software from the Windows world into Linux, we have first experience. We can give that experience also to you. Software optimization regarding speed. As you know, there are different concepts in x86 processors and ARM processors to speed up the application, what is necessary, what must be done. Finally, release management. We have a system with a clear release management, because our intention is to reproduce your vision computer day by day, years by years. So this is also important to discuss and to agree on the way of release management. And finally, embed your solution is there a way to reduce the effort of hardware, the effort of peripherals, the effort of cables, whatever? We are open. IMAGO is an engineering company. We have many engineers, very good engineers, a good fantasy, and together we find a new solution.
And finally, if you're interested in how you can stay in touch, what our services are, about information and trainings, as we've already mentioned, we have a YouTube channel where we post like once every quarter year a newsletter in form of a visual newsletter, which is called IMAGO TV. So you can imagine watching the news every evening, just instead of seeing Tagesschau, for example, in Germany, it would be IMAGO TV. Or you can also sign up for a newsletter on our website. We also have a special area on our website where you can ask for specifications and documentation, so for all the hard facts about our products. Newly available is also a video training for our Vision Cam XM, which is very interesting if you're, for example, new in programming with Linux. This is also available upon demand, upon request. We have a blog on our website and also a LinkedIn page, which we keep updated weekly. And we are often present in magazines with articles. And if you're already a customer, then or maybe if you want to become a customer, then it's important to know that we have qualified services via our ticket system. And you can also buy direct support if you need it. Apart from that, you can ask for a macro system, which is tailored to your needs to start your application software development faster. As Carsten already said, we have real big expertise, especially in the engineering part, so we can help you with whatever questions you might have. We also have individual trainings and online support via GoToMeeting. Yep, so thank you. That's the end of our little presentation. We are in Hall 1, that way, and in booth 458, so if you'd like to come over for a cup of coffee and maybe some technical talk with Mr. Strampe, then yeah, we'd happy to meet you there.
Thank you for your attention. Thank you for your time. Thank you, Vivien.
Thank you too.